Hello girls. Today we are going to discuss about uh, linked list using dynamic memory management. In the last class, we have discussed about implementation or realization of linked list using arrays. Today we will be discussing that linked list implementation using dynamic memory management. So, how these linked lists are stored and how the memory is allocated and how it is released. That is what we are going to see today. See, linked lists need not be stored in adjacent locations. Actually, arrays are nothing but sequential memory locations or adjacent memory locations. So when you try to implement linked lists using arrays, what happens automatically? They are stored in adjacent memory locations. And we have also seen what are the drawbacks of storing linked list in the form of an array. So instead of using arrays, if we try to allocate the memory as and when needed, that is what is dynamic memory management. Say linked list. So linked lists need not be stored in adjacent locations. Individual elements can be stored anywhere in the memory. So they can be stored anywhere in the memory. I mean, if you are having some space here, you can, at place A, you can store some elements there. And somewhere at place Z, you can store there. Okay, wherever you find empty spaces, there you can store the memory. So what is actually dynamic memory management? See, during runtime, that is the execution of the program, as per the need, a node is allocated. That is, memory is allocated for a new node. That is what is dynamic memory allocation. New node of the list will be created dynamically. Dynamically in the sense as and when needed. That is what is runtime during the execution of the program, as per the requirement of the program. A node is allocated. Not a node is allocated in the sense memory is allocated to that particular node. So a linked list thus maintains the data elements in a logical order than a physical order. Physical order in the sense maintaining them in consecutive sequential locations that comes in a physical order. But here we are storing the elements wherever there is place, wherever we find empty space, but still they are in order. So that's why we are saying here they are maintained in logical order rather than physical order. So here it is, the main point is linked list separates the physical view from the logical view. Physically how it is represented doesn't matter in linked list representation using dynamic memory allocation. The thing which matters is logical view. Okay. Next, an empty linked list is a head pointer with the value null. So already we have seen a linked list will have nodes. To point to the first node of the linked list, we will have a pointer called head pointer. Yes, that is what indicates as, that is the pointer which takes the first node of your linked list. That's what is head pointer. So if an linked list is empty, that head pointer is set to null. So an empty list is also called as a null list. The length of a null or empty list is 0 because there are no elements in that list. It is empty. So we are using null to represent that empty list. It is, so the length of that null list or empty list is what? 0. Next, some important points here are that nodes may not actually reside in sequential locations. Yes, there is no hard and fast rule that all the nodes should be in a sequential order. They can be placed anywhere in the memory. I mean, wherever there is free space. The locations of nodes may change during runtimes of program. Yes, as with different executions, I mean, execution 1, execution 2, execution 3, the allocations will be changing because the same memory spaces may not be available for the for every execution of the program. The same program is executed, but once you execute the memory allocation will be different. I mean, the memory places allotted will be different. But the second time you execute the same program, the memory allocated will be, places allocated will be different. I mean, the addresses will be different. So that is what is dynamic memory management, right? Next, while writing a program that works on list, one should never look for a specific address except when one tests for 0. So you should not try to read what the address of that particular node is, because they are dynamic. They will never be in an order. The addresses will be different. So if you try to read those addresses, you will get confused. Oh, this is what is the address of the first node? Is this? So what is the address of the second node? Is how? What is how much difference between these addresses, I mean places. So you should never try to read the address of that node except when the node is showing you the link as the pointer to that node as link as 0 or null. That means it represents the end of that pointer. Okay, so why we should treat that particular end means that is where it indicates that the list has ended, and also for the next list to start you have to store the address so that from that place you can start storing the next list. Okay, to implement linked list, the following are needed. What are they? A means for allocating. See, a means for allocating memory for a node that has at least one link field. So, if you have a node, that node should have at least one link field. So, with a node exists is a combination of data and links. So, if it is a single linked list, it will have only one linked list, one link field. If it is a double linked list, it will have two link fields. But the hard and fast rule is, if it is a node of a linked list, it should have one link field. Why? Because it should point to the next node in that list. A mechanism to verify whether the allocation is successful. So when you are trying to allocate the memory, is the memory allocated properly, and whatever data you want to store in that particular memory location, is that stored successfully or not? That is what we have to check. So for that we have to use some particular procedure. So next, a mechanism to release the allocated node and add to free pool of memory as and when needed. So when your program execution is finished and there is no need of storing the values still in the memory, so you have to release the memory. So for that also you need a mechanism. So how you are going to implement this, we will see in the next steps. So the mechanism is also needed to release the memory and add it to the free pool, and already existing free memory we will be adding these memory places also, so that they can be used by other programs. So to verify the memory allocation process, the address returned by the memory allocation function is compared with the value null. So whenever you are executing a process, whether memory is allocated properly or not, what the thing which you have to compare is the address returned by the memory location function. It is compared to null value. If it is a non-null value, it indicates, if it is a non-null address, it indicates that the process is successful. If it indicates a null, then either it is the end or there exists some, I mean, it's unable to allocate memory to that particular node. So again, we have to verify that what, because of which situation it has returned the null. Okay, so whenever memory allocation function allocates memory, if it returns a null value, then it is the end, or memory allocation is not done. If it is not returning a non-null value, that is nothing but an address, then the memory allocation is done properly and it is successful. Next, what is dynamic memory management? See how the memory is managed here. To allocate your node, to allocate memory to the nodes. Let's see. First, this is how the memory is this is how the memory is allocated See, all the global variables and program instructions, that is the code uh, methods, what I write, are stored in permanent storage area, and local variables are stored on stack, and all other memory which is left free is nothing but which is a memory which is available with the heap. Okay, so this is how the actual memory allocation is done. So the global variables and program instructions are stored in permanent storage area, these two. Next, local variables are stored on stack, and the left out memory, free memory, is represented by heap. So the program instructions and global and static variables are stored in a region known as permanent storage area. Okay, local variables are stored on stack. The memory space allocated between these two regions is available for dynamic allocation during the execution of the program. Okay, with the area between the stack and the permanent storage area is called heap because it is what is dynamically allocated during the execution of the program. Though the size of the heap keeps changing when a program is executed. Why? Because creation and deletion of variables that are local to the functions and blocks, they are allocated memory in the heap. So because of this, the size of the heap keeps changing. So when you create, you have to allocate memory. So some size is occupied, some place is occupied in the heap. So the size changes. And so when you are leaving the game, the variables are deleted. So again the size of the heap shrinks. So creation and deletion of variables that are local to the functions and blocks. So this will cause the increase and decrease in the size of the heap. Already existing size only also changes with time. So this keeps on changing with the execution of the program. So a new dynamic variable created by a program consumes some memory in the heap. So whenever you're trying to create a new variable, so where it is stored on heap. It consumes some memory in the heap. Next. So in C++, how you are going to manage the dynamic memory. Okay. How you are going to allocate memory dynamically in C++ with new and delete operators. So we will discuss what this new and delete operators are. So C++ enables programmers to control the allocation and deallocation of memory in a program. So it is the language. This language allows us to control allocation and deallocation of the memory by the programmers only. So the users can allocate and deallocate memory for any built-in or user-defined data structure. So for built-in structure or user-defined data structure, you can allocate the memory dynamically and also deallocate it. So how you will allocate the memory? How to allocate the memory? You will be using new operator. The new operator creates a new dynamic object of a specified type and returns a pointer that points to this new object. So carefully listen. So what is this new? New is an operator that creates dynamic object. Okay, I mean as you are trying to run the program at runtime, it creates the object of a specified type. You have to specify the data type of this object and returns a pointer. So what it returns, this new operator is going to return a pointer that points to this new object. So the new object which is created by this new operator, it will be pointed to by this point. Okay, see here, pointer type variable is equal to new space data type. So see here, first this is the syntax, pointer type variable, and here new is the operator and here is the data type. So here int pointer number. So this is number is a pointer. So in this pointer, what you're storing? New int 20. So 20 is the value that you are storing in this pointer. Okay, and this pointer is of which data type? Int data type. So this new will allocate memory to this number and store the value, and this value 20 in this number. Okay, here say time. For time also you're creating a time pointer. So in this time pointer, what you are doing, you are creating a new object and storing time in this time pointer object. Okay, here you see date, date, birthday date pointer, and you are creating two pointers here, today pointer. So in this pointer, you are this pointer will storing the value. It is pointing to the value. Say new allocate new operator. It will store the date 21 1995, and for today this new date 21 2000. So this is how your new operator will work. So again, once we will go to the definition, the new operator creates a new dynamic object of a specified type, see, of a specified data type, and returns a pointer that points to this new object. So what it returns? It returns a pointer. So that is the reason first we are declaring this as a pointer here. What does this symbol indicate? It indicates that this is a pointer. So new will return what? Pointer. So that to store that pointer, you have to declare that as a pointer, the variable as a pointer. So that is the reason first you declare it as a pointer, and then take the value from that new operator and store it in this pointer. Okay, so this is what is your new operator is. Next, null pointer. So what is null pointer? So null is a special constant pointer value that is used to give a value to a pointer variable that would not otherwise array. And if you don't have any value, if there doesn't exist any value, then you will try to put null in that place, then that is called null pointer. So it can be assigned to a pointer of any variable type. For null, there is no any data type, there isn't any data type. For any type of data, you can assign, you can put the value as null. With earlier C++ compilers, if all the memory in the heap has been used and you cannot create at the requested dynamic variable, then it returns a special pointer named null. I mean, in the old C++ compilers, when there was no, when the memory was full and the new pointer was not able to create any dynamic variable, then to indicate that the memory is full or to indicate that it is not able to create a new dynamic variable, it used to return the new operator used to return a special pointer called null. But with current compilers, there is no such case. Automatically, it will throw the exception standard bad allocation. So it will specify that it is a bad allocation, and the program automatically alerts the with an error message. Okay, so this is what about your null pointers. Next, delete operator. So delete operator. So when you are allocating the memory, automatically you have to release it when the work is over. So for this purpose, you will be using the delete operator. The object created exists till it is complete, explicitly deleted, or till the function or program runs. So when what is the lifetime of the object? What is the lifetime of that object? It will be existing till it is explicitly deleted, or till the function or program runs. Till your function or program runs, the object will exist, or it is deleted by someone. It is deleted by implicitly, not by itself. It will not get deleted. It has to be deleted by someone. So who will delete it? Who will destroy it? So see, to destroy a dynamically allocated variable or object and free the space occupied by the object, the delete operator is used. Okay, so the dynamically allocated variable or object which was created by using new operator, it has to be freed to give free up the space which was occupied by that object. For that purpose, you will be using the delete operator. So what you will be deleting? You will be deleting the pointer. So if you want to delete this number, so you have to delete number pointer. You have to delete this time pointer. You can delete this birth date and today pointers. So this is what is about your dynamic memory linked list implementation using dynamic memory management. In tomorrow's class, we will discuss about insertion and deletion of nodes in linked list, and how will you insert. Again, in insertion also there are three different types in the sense ways to insert at the starting, in the middle, and at the end, and how to delete these nodes also. So this is what your next topic is. So if you have any doubts, ping me. Thank you.